Hi, everyone. My name is Brian Miller. I am the Director of Strategic Education Outreach for Wonder Workshop, and I'm really excited to be joining in with all of you today and getting ready to talk about our curriculum with Charlotte Cheng, our curriculum designer at Wonder Workshop. And she's going to be jumping on in a moment to introduce herself and to also explain and share more about what is happening with our growing Wonder Workshop curriculum. So we're really excited to have Charlotte joining us. Charlotte is joining us from San Francisco in our headquarters. I am currently on the road in Tampa. I see Eileen Peters is on, also in the Tampa area, who I will be seeing this weekend at Ed Camp Tampa Bay. So really excited to be joining that whole crew and working with some schools over the next couple of days. So at this point, I'm going to go ahead and I'm going to turn it over to Charlotte. So Charlotte, would you like to join me?
Sounds good. Here we go.
All right. Take it away. Thanks, Charlotte.
All right. No, thank you, Brian. Welcome, everybody. So my name is Charlotte Cheng. I'm the curriculum designer at Wonder Workshop. A little bit about me. I started off at Stanford with a bachelor's in cognitive science. Then I got a master's in elementary education at Stanford. And I've been teaching on and off in classrooms and designing curriculum for the last 15 years or so. So if you guys are ready to roll, I'm going to share my screen here. There we go. And let's turn the chat on. So while I'm doing this keynote, I'm going to be asking you guys questions. So please have your chat window open. I'm definitely going to be looking at your answers as well. Okay, so I'm going to stop my video. There we are.
Charlotte, I'm going to jump in real quick.
Yes.
So for everyone that's joining, if you have any questions throughout the way, you have the opportunity in the question and answer box to type in any questions, and those will pop up on our end. Charlotte will be able to see those, and she'll be addressing any questions that you have throughout the way and at the end of the presentation. So be sure to use that Q&A box and also the chat window. All right, thanks.
Thank you. Yes, and I'll definitely save time at the end to address those questions that you put in the Q&A. All right, here we go. Let's see. Brian, quick question. Can you see that chat window in my bottom right?
Nope, you're good.
Awesome. Okay, cool. All right, so welcome to Wonder Workshop, our K-5 Learn to Code curriculum. I'm really excited to walk you guys through this curriculum. We were hard at work developing this starting last October, and we launched it in June at ISTE. So the first question I have for you guys is, how many of you guys have already used Dash and Dot in the classroom? I'd love to know. Any responses here? Well, I'm going to be looking at chat here, but I know some of you guys already use Dash and Dot in the classroom. But just in case you guys don't know, Dash and Dot are two adorable robots that teach kids how to code. They basically bring STEM to life through robotics. And with these robots, you actually get 5 free apps and that help kids level up their coding experience through different coding environments. So kids can start as early as pre-K or first grade with apps like Go and Path and Xylo, where they don't need any reading at all, and yet they're still getting exposure to concepts like sequencing and loops. Then they can level up that coding skill with our apps Blockly and Wonder, where Blockly is block-based programming similar to Scratch or Code.org, and Wonder is basically a brand new type of programming paradigm, where you're actually designing state machines similar to decision trees or flowcharts. An example here I have is, for example, in Xylo, you're actually manipulating chunks of music. So you're learning about sequencing that way. And every chunk of music that the kids compose, they can loop through as many times as they want to. And it's a little accessory that you add to Dash, so then the Dash plays that music when you press play. Now, for example, in Blockly here, you have a program where you're using all sorts of different types of blocks. If you have done Code.org or Scratch before, this will look very familiar with you. Blockly is extremely robust. You can use functions, conditionals, and variables as well. So before I jump into the curriculum itself, I wanted to talk a little bit about the school bundles. I saw through your questionnaire and submission that some of you guys have recently bought our school bundles, the Club Pack, Classroom Pack, and Tech Center Pack. And I wanted to walk through that and tell you guys what you're getting in that bundle and make sure you guys know. So one question I have for you guys is, what do you have in your Wonder Workshop robotics collection? Now, Brian, I might not be able to see the chat progress. Do you mind reading out a couple questions for me? Answers?
Yep, as soon as I see stuff roll through.
Sure. So
Elizabeth Connell says that she has 10 dash, 8 dots, and all the accessories. Suzanne Costner says dash, challenge cards, and curriculum notebooks. Lots of people are saying that they have multiple dashes, multiple dots, multiple curriculum packs. So it seems like a lot of people have more than one dash and dot that they're working with.
That's great to hear. That's important if you're trying to implement this in a classroom.
Ooh, and someone even has the new Q.
What? That's congratulations.
Daniel Caspedes has the new Q. That's awesome.
Exactly. That's great to hear. We're actually currently testing Q in classrooms as I'm developing the middle school curriculum as well. So I'm excited that you guys are getting your hands on that. So let me walk through those bundles just in case you don't have them. So, on our store, we have challenge cards as an item that you can purchase. That's 72 sequence coding cards. Sounds like some of you guys already have that. You can level up that experience by getting the Learn to Code curriculum pack, where you get those cards plus a curriculum guide plus a subscription to our online Code to Learn lesson library. That's cross-curricular lessons that are project-based just for you guys. Now, if you bought one of these packs, right, you get a club pack, that's 2 dashes, 2 dots, all of the accessories, classroom pack, that's 6 dashes, 6 dots, all of those accessories and that curriculum and that subscription. And the Tech Center pack, you get 12 dashes, 12 dots, all that curriculum, and all those accessories. Now with all of those packs, for every dash you get another box of challenge cards. I break it down that way to help you guys figure out what kind of system works best for you. Now, after talking about those bundles, I wanted to give you guys a window into our curriculum design thinking when we were developing this curriculum. Oh, excuse me. I might have had an extra, there we go. So before I jump in, I wanted to ask another question to you guys. How have you integrated design thinking into your classroom? I know it's a very popular phrase, but we also know it's a very important thinking process to integrate into your curriculum. Brian, do you mind shouting out some answers?
Sure, once I see them come through.
Let me see if I can.
Sharon says that they have posters on the wall, and we start with that when we begin a new challenge. Jenny says we use it with all the coding activities that they do. Some use design thinking and engineering challenges. Elizabeth said that she would like to incorporate design thinking with the robots, which is really exciting. Karen says that she has a STEAM lab and lots of challenges using lots of dash and dots. People are asking if they can get the copies of the poster file.
Well, yes, actually it's part of our online lessons already. So I'll point you guys to that at the end, for sure. But I'm glad to hear that you guys are already thinking about using design thinking paired with our robots. Now I want to go a little bit macro with you guys here. So we actually use that design thinking process when developing curriculum that you're going to use. So the first phase, like you see in this little design thinking process infographic, is understanding who you're designing for and what problems do they face. So guess what we did? We interviewed a lot of teachers and administrators. We visited a lot of classrooms to see how people are using their robots in their classrooms. And we also had online surveys. Furthermore, we just went out on the road. You might have seen us at FETC or TCEA or ISTE or Q. Every single time we're at one of those conferences, we actually arranged one-on-one meetings with teachers to get a sense of how they were using the robots in the classroom, how we could support them, and what kind of resources they needed. And Kamala asked, yes, I will be sharing this presentation later as well, and we are recording this session, so don't worry about that. So one question I wanted to ask, since we were out on the road, we saw lots of teachers. Have you visited one of our booths at an EdTech conference? And if so, which one? Because I really love seeing your faces there and talking to you guys one-on-one. Just curious if anybody was there. FETC, Deb, I recognize you. Yes, Susan, great, FETC. That was our first conference. If you were there, I had a very, 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 very initial version of a challenge card to show all the teachers to get feedback on that. Oh, okay, great. Yeah, and just so you guys know, we are planning to go through that same route next year, FETC, TCEA, ISTE, and I also believe Q, right, Brian?
Yes, we're going to be at Q, and then we'll also have a couple of other smaller conferences that we'll be going to as well. NACE is the next upcoming one that we'll be at, and the CS for All Summit in St. Louis next week.
Great. Yeah, and at these conferences, please make sure to stop by. I always have something new to show where I'm trying to get feedback from teachers so we can improve that. Now from there, we interviewed all those teachers, we talked to them, we looked at these surveys, and what we did was we figured out what educators need. We identified these key components. And the first thing we said was, you know what, they need scope and sequence content. And I noticed a lot of teachers, they use code.org, and you also use CSTA and ISTE as sort of guideposts on what to teach your students when it comes to coding. And the other thing we realized was we needed adaptable curriculum. Talking to you guys, you had all sorts of different types of classrooms. Some had maker spaces, some were in libraries, some were in a tech lab, some were in a classroom. So we needed a curriculum that would work in all those different types of environments. Next, we wanted to make sure we had differentiated and personal learning. Right, students' coding levels are completely different within a grade. And so students need to be able to work at their own pace, but you also need to have both personalized and group assessment strategies, because with the robots, you have multiple kids working with each robot. And the other thing was they needed hints, and also they needed extensions. So hints for those kids who are struggling and extensions for those kids who are really excelling. Last but not least, was cross-curricular extensions. I'm noticing people saying, what about NGSS? Completely understand. We knew we needed content that aligned with Common Core and NGSS as well. Now we took all of those components, we were like, gee, how are we gonna put all this together in a curriculum? The next thing we did was we went to those experts and asked, how would you integrate this? What are examples that you enjoy? So the first people we talked to were, guess what, code.org. In fact, Kiki Protzman, who developed the curriculum for code.org, is one of our board advisors. So I had a lot of one-on-one chats with her about, hey, you guys have built this amazing platform for kids to learn how to code. What are you missing? How can Dash and Dot, how can our company support you guys? And she said, you know what, Charlotte? It's that collaboration piece. It's also that hands-on piece. They're working on the computer with code.org, but she said, they really want to learn how to apply those coding skills to a hands-on experience. Furthermore, we interviewed people at CSTA and ISTE, and we noticed that there were specific standards where students are supposed to take on roles, to collaborate with each other, to work on projects and solve problems at the same time. So from there, we're like, okay, that is great information. We want to take that and align our curriculum to all of those needs. Now, before I jump in, I already noticed you guys saying NGSS, etc. What standards do you guys use to develop your curriculum? I'm seeing NGSS, that's right. Any other ones? Does anyone use CSTA or ISTE? Yep, Common Core State Standards, ISTE, that's right. NETS, I'm gonna have to look into that. Thank you, Kristen. All right, so now I'm gonna reveal our scope and sequence.
Charlotte, NETS is the National Educational Technology Standards.
Thank you so much, that's good to know. So basically, we wanted to reveal our scope and sequence. Now, taking all of that advice, looking at all of those standards, and then also saying, you know what, we want to partner with code.org. We really admire what they're doing. What we did was we created a scope and sequence, coding levels A through F, that align with code.org's new course levels A through F. And our curriculum is actually integrating code.org content into the lessons to help kids bridge that gap, where they're going from the computer to the robot as well. And if you see here, the reason why we don't say grade level, we do have a recommended grade level, is, as you guys know, grade level does not necessarily equate to coding level, right? So we wanted to obfuscate that. We didn't want kids to be tied to a certain grade level. As you can see here, in each coding level, you're addressing different coding concepts. So in coding level A, you're just doing something as simple as sequences and loops. And as you're advancing up in level E, for example, you're dealing with more advanced loops. You're dealing with conditionals and also functions as well. The other thing we did with our curriculum listening to our educator needs, is to really address the ecosystem of a school. We understand within the school ecosystem, you have different opportunities where students can practice coding. There's that after-school program where kids are working with the robotics team. How many of you guys are in the Wonder League robotics competition? They're also, you know, after school, they get a little bit more hands-on and more time with the robots. We have our tech teachers, right? You've got those tech labs, you're working with multiple grade levels throughout the day. And then you have classroom teachers who want to apply that coding to cross-curricular content like math, English, science, art, and social studies. So we were like saying, we said, you know what, we need curriculum that basically helps the entire ecosystem of the school. So with that, we came up with our curriculum solution. And this curriculum solution has 3 elements here. We've got our challenge cards, we have the curriculum guide, and we have our free online coding lessons as well. Now, before I dive into this, has anybody, and I heard some of you guys have challenge cards and also the curriculum guide, have you guys tried or looked at our K-5 Learn to Code curriculum? Perhaps the coding lessons online, perhaps digging through some of those challenge cards, perhaps letting the kids try out those challenge cards themselves. Sabrina's tried it out, awesome. Yeah, I started looking through the curriculum guide and the free online curriculum, awesome. Yeah, I haven't rolled them out yet. Awesome, A1.1 was a great success. That's good to hear. That's great. Well, in case you guys haven't tried out the cards, I wanted to walk you guys through that. Now for the first 2 components we talked about, the challenge cards and the curriculum guide, these are teaching tools, okay? These are tools that you can use in your classroom to help you teach coding. Now, the challenge cards are 72 sequence coding cards. There's 6 cards per coding level with that scope and sequence in mind, and these are also aligned with code.org and CSTA. The curriculum guide provides the solutions, hints, and discussions and curricular connections, cross-curricular connections for every single card in that box of challenge cards. And it also includes assessment and implementation strategies and additional resources as well. For the challenge cards here, I'm going to break you guys down here, a sneak peek in how we developed the challenge cards. Like I mentioned at FETC, we had a really, really rough prototype. And down below here, you can actually see the evolution of our challenge card design. We took a long time prototyping these cards out, feeling the right paper, the right size. We even talked about rounded corners to make it feel more friendly. And with that in mind, we developed these cards. Like I said, these 72 cards. Now on every side, on every card, one side has a story. And the reason why we developed a story for every card is we realized that we wanted to give students a reason why they're completing a challenge. We wanted to answer that question, why? You know, why am I doing this? And so these stories basically help set up an objective, a specific objective. And we also paired it with a very colorful illustration to keep it really attractive. And on the other side, we have all this other content that helps them prepare for that challenge and complete that challenge. At the top, you see we have the coding level, we have card numbers, we have what robots and accessories you need, what additional materials you might need, we have instructions and even sometimes bonus extensions as well. Now I know that card number has come up a couple times of what was the card numbering system here. So within each coding level, we have 3 sets. We have the first set, which is 1, second set, which is 2, and the third set, which is 3. Each set addresses a different coding concept. So for example, here in level B, the first set addresses sequences. And any card that says B1 means that it is part of that sequences set. And you can tell that the 3 of them go together to tell a story by looking at the numbers. 1.1, 1.2, and 1.3, for example, here are all cards that deal with Dash being a collector. And then the next level is loops with Dot. So every single set has sort of a theme and a storyline that goes through. I know they're going to have lots of questions about that, so feel free to put those questions in Q&A, and I can make sure I can address those questions at the end. So don't forget to put them in Q&A because that's where I'm going to be looking for questions. Now, the curriculum guide is that second component of the curriculum. No problem, Laura. I know there's a lot of things to type in. But yes, I just wanted to make sure we want to put all the questions in one section so I can make sure I can address them, okay? All right, so the curriculum guide here, I wanted to walk through these components. Yeah, I know some of you guys have that curriculum guide. I know it's a thick book. It's a lot of content, so I wanted to break that down for you guys, all right? So the different curriculum guide elements include an introduction, where you talk about how to set up your classroom, get your robots and tablets ready. We talk about implementation strategies and best practices as well. The other section is talking about assessment strategies. How are you going to assess your students' work and build that student portfolio for an authentic assessment, not just a grade A, B, C, D, right? Next element was the solution guide, which I talked to you guys about. For every single card, we have 2 pages full of content with a suggested solution, with hints, with extension questions, and cross-curricular extensions as well. And last but not least, we added some resources in there just for you guys. There's student-facing resources like checklists and worksheets, and there's also tips and tricks for you guys to use in your classroom as well. Denise, yeah, there shouldn't be just one solution to the challenge. That's why we say suggested solution. The suggested solution is a solution to the challenge, but there are multiple ways to solve a problem. So I want you guys, when you're using the cards, to encourage your kids' creativity. Just because their solution doesn't look like the one in the curriculum guide doesn't mean it's wrong. Yeah, some of them are definitely open-ended. In the beginning, they're less open-ended. They're more like, it's more walkthrough, it's more guidance. Near the end, it's going to be a lot more open-ended for sure. Now here's the question. After seeing all those elements, I wanted you guys to take a brief look at them again, the introduction, the assessment strategies, solution, and resources. I wanted you guys to take a pause and think about this. What else would you like to see in our curriculum guide, knowing that those are the sort of the buckets that we addressed? You can answer them at your own time. I'll keep looking over here, but I want to honor the time, so I'm just going to continue, okay? So that first module I told you about, getting started, the curriculum guide basically helps you set up your tablets, apps, and robots. We give you lots of strategies and hints, and also how to set up your classroom workspace. Now, another resource I want to point you guys to as well is blog.makewonder.com. That's our blog, and Derry Stevens, who's been running our teacher community, she has been like filling that blog full of resources just for you guys, all right? We have teachers writing about how they set up their classroom. Others are talking about how to build a storage cart. What are the best storage solutions for your robot? So definitely go there to check out more resources. We also, like I said, have worksheets and resources here. There's checklists where kids can check off the challenge cards as they complete them. There's planning and reflection, because I'm telling you that reflection piece is often missing in a lot of the coding content I saw out there. And that's really important. You're talking about, hey, how did I debug this problem? How can I use that strategy when I complete the next challenge? Now, planning is also important too, obviously. So we have different types of planning worksheets where kids can plan out their code before they actually implement them. And last but not least, we have these reference sheets, challenge card tips and tricks, troubleshooting, and walking through the stages of problem solving as well. Kristen, yeah, check the video, but I'll have that link at the end as well. Assessment strategies. I love assessment, actually. So the reason why I love assessment is it's a time for students to celebrate what they've done, right? And that's why I wanted to point you guys to this concept of building a student portfolio. It's not just, one piece of work here, one piece of work there. That way they can actually see the way they've grown and develop their coding skills. And within this portfolio, I recommend including screenshots of the kids' code, videos of their dash or dot completing that challenge, and also those worksheets I told you about. That's a great place for them to keep their portfolio. This can be a physical portfolio, basically, where it's like a binder, or there's some strategies with Seesaw, Google Classroom, or even OneNote, where you can help the students compile those things online. And basically, part of our curriculum guide, we also include an evaluation rubric. So as you're reviewing that portfolio, perhaps with the student, you can walk through that rubric and say, hey, how did you demonstrate your learning? And are you using the right communication skills when you're collaborating with your students? You'll be able to see that evaluation rubric online and also in the guide too. Now, the last component, like I said, was that solution guide. With 2 pages of content for every challenge card. And here's an example page I squashed it up into one page so it was easy to read. But as you can see, within that page, you're looking at estimated time, that suggested solution I was telling you about, the hints that you can, where you can offer those questions to guide those kids to the right answer or another solution. There's discussion questions you can use at the end after they've completed the challenge, and also cross-curricular extensions where they can extend that challenge and that activity to incorporate math and ELA concepts as well. What I also recommend, I've been talking to a lot of teachers since this has been released, is that think about perhaps having that curriculum guide open and available for your students to use. So as they're completing those cards, you know, if they're at the right age range, maybe 3rd through 5th grade, have that curriculum guide out there so they can look at that solution if they're really stuck. You know, they can basically be more independent learners trying to get those hints and those extensions themselves. Now, last but not least, we talk about implementation strategies here. And I had a lot of questions about this that were sent in. But within the curriculum guide, we talk about 3 different ways you can implement the challenge cards into your school. One is whole classroom instruction, which I recommend for K-2 students, because, you know, those kids, their reading ability might not be up to snuff. So the best way to do it with that is to introduce the coding concepts through unplugged activities, which we have in our coding lessons, and also whole classroom instruction where you're completing a challenge card as an entire class and you can walk them through. Now, for more older students, you can do differentiated groups. So you can group students by coding abilities and assign them challenge cards that match that coding ability. So it's more self-paced learning and independent practice. And last but not least, I know a lot of you guys have that out there, those learning centers and those maker spaces. You just have a little Wonder Workshop corner. Right? You have that box of challenge cards, you have all the kids' journals set up there or portfolios, and you have the worksheets available so they can just go to that center, complete the card that they're on next, fill out all the worksheets, and be done. And that's basically a center you can rotate through as well in a classroom. So these implementation questions that I got in were a lot, right? And I basically realized there was a theme. The major question was, how do I implement this curriculum for multiple grades and classes? It sounds like you guys got, you know, your robot collection for a school, and then you're now trying to figure out how can I have multiple classes go through my classroom, like my tech lab, or I have a set of robots that need to rotate through different classrooms as well. So I wanted to address those specifically, and this content wasn't in the curriculum guide, but I wanted to walk you guys through some of these things as well. Step 1 to help you do that is to manage your robots and devices. And what I mean by that is at the very beginning, before your students even get their hands on these robots, name your robots. Within the app, you get to name those robots. Oh, Jenny, wow, 1,100 students. Very impressive. So name those robots, and the second key point is to number those tablets, okay? So you can number them 1, 2, 3, 4, 5, 6. I heard of teachers who name the robots by number, 1, 2, 3, 4, 5, 6, 7, and then they number their tablets 1, 2, 3, 4, 5, 6, 7, so that every single time the same tablet is being paired with the same robot. In case students have recorded their voices on that robot, they basically can go right back to that robot. They know which one to grab. The other strategy that I wanted to talk about was, oh, did I unmute myself? Oh, was that you? Okay, sorry. Sorry, we've got another teammate here, June, who just logged in here. Sorry about that echo. The number thing is establish a cart or other storage system, okay? Depending on how many robots you've got. You might have 2, you might have 6, you might have 20, who knows? I showed an image here of a storage cart, something that's mobile. So, you know, in case you have that situation where you're going to multiple classrooms, you can push that cart, you have your tablets, you have your robots, you have your cards, you have everything that you need in that cart, and it's mobile. Now, I know there's been a lot of feedback that we should make that cart, and we are working on that, but until then, we have a blog article, like I pointed to you guys, blog.makewonder.com. There's an article specifically showing you different strategies that you can do right now with resources that are available online. So I definitely recommend that for that teacher who's moving through multiple classrooms. The second component is student tracking. Now, I know we've got feedback about needing student accounts. We are hard at work and really sprinting towards getting you those student accounts and teacher accounts. Now, until then, that curriculum guide actually provides you with the resources you need to track with your students via the worksheets, okay? Once again, I talked to you about that Wonder Journal or binder, having 1 per student. And within that, have those checklists so they can keep track of what cards they've completed complete it. That way, the next time they come to your classroom, they know exactly which card they're going to, right? They know exactly what worksheet they're supposed to fill out, and they know exactly how they're going to reflect on that work at the very end. And last but not least, establish programming etiquette. Yeah, Angela, like I said, you can number the robots and then number the tablets and then basically match those up. So robot one, number one goes with tablet number one every single time. So the kids always know which robot to go to. They're like, oh, I was working on robot 3 with tablet 3, and then they can go back to that one immediately. So in that thought process here, then the third component is establishing programming etiquette. We got feedback about this too. Oftentimes, and you guys know this, when the kids get to the iPad and they open up Blockly, what do I mean by tablet? Like an iPad or, Android tablet, where you're going to have that app, the Blockly app, okay? All right, so as you know, establishing programming etiquette is when that kid grabs that tablet and opens up Blockly, the first thing they do is they just start programming, right? Well, I don't know if you guys know this, but if you click on the Blockly menu, there's a section called Create New Project. And you can actually at the very top type in the name of your project and then create that new project, okay? And then if they start coding from there, it automatically saves that project. So the next time they go to that same tablet, they can go back to the menu and actually access that project again. But the key is to make sure that every single time they start a new card, they got to name that project and they got to create it. Don't just start from scratch from that blank page. Same goes with when you go back and the other reason why you want to do that is that sometimes when you open up that tablet, right, another student's work is on there from a previous group. Now, if that group just starts coding on that page, what happens to that previous group's program? It goes away, right? So always, always, always have them create a new project or go back to a project they had been working on before. And then last but not least, a great way to just double check, make sure, just have the kids take a screenshot of their work at the end of the class, just in case. If they lose their program, there's a photo out there that will help them recreate that program as well. Yeah, so I'm gonna pause, let you guys sort of put some Q&A in, put some more questions in Q&A. I know this is the big question about implementation. So I'm just gonna pause, give you guys like 5 seconds, go to that Q&A section, type up some questions, and I'll try and address them later. Yeah. Okay, Angela says Wonder Workshop. Do you mean the Wonder app, Angela? If so, the Wonder app actually has a Wonder key section. So if you go to, I believe, free play, right? On the app, you go to free play and you create a new program there. And then you can also name your program there. So make sure they always name the program because we always, if they don't name the program, we autofill with something silly, right? Something like bananas and mushrooms. And so they'll never be able to find that again. So once they do that, at the end, they have this code key, and they can, if they write down that code key, even though they're not using the same tablet, they can put that key in, and it unlocks their program again. So that's another way to do it. All right, I got to move on, guys. I know we've got, time is precious here. So the final component that I talked about were lesson plans. Like I said, the first two are teaching tools for you guys. It's that adaptable curriculum which you can choose how to use it in your own way. But I do know that we've got teachers out there, and I was just like this, who want a little bit more guidance. What do I do day 1? What do I do day 2? What do I do day 3, right? And that's why we created these lesson plans. Now, before I show you guys what these lesson plans are, I'd love to get a sense of what kind of lesson plans have you used for your school or classroom? Do you guys use lesson plans or write your own lesson plans? That would help me get a sense of how you guys use lesson plans in your school. I agree, code.org has great curriculum, Angela. Yes, I've heard of Understanding by Design. Yeah, write my own. Yep, I like writing my own too. Yep, code.org is great. Someone used lesson plans from our website. That's good to hear. Awesome. Great. All right, so now I'm going to walk you guys through our coding lesson plans, which I think some of you guys already use. Oh, Codable's got great lessons too. So here we go. This is our Learn to Code curriculum. It's 36 lessons, all right? All free on our website right now. If you go to education.makewonder.com, you can click on curriculum and you'll find the Learn to Code curriculum there. For every single coding level that I told you guys about, there are 6 lessons. And within those 6 lessons, one of them is an unplug lesson. So basically it's unplugged, they're not touching the robots. It helps them get acquainted with that coding concept before they even apply it to the robots. 4 of them are tied to the challenge cards that I was talking about. And that final lesson every single time is an assessment lesson. It's project-based, it's design thinking, where they're actually trying to solve a problem using that robot, and they learn about the different phases of the design thinking process. So that's basically our scope of the lessons. You've got 36 lessons across 6 different coding levels. Now let's see. In a lesson here, there's different sections in a lesson. The first one is getting started. Now this is a way for you to introduce coding concepts to the students as a whole class. And we'll talk about basically real life examples about how a coding concept is used. For example, you guys might be familiar with the peanut butter jelly sandwich sequencing challenge, where you basically have to walk through every step that you need to take in order to create a peanut butter jelly sandwich. That's a similar activity that you would do in the getting started section of the lesson. And once again, I mentioned that code.org connection. We actually point to code.org content that the students have probably already used. So that basically helps them make that connection and allows them to apply what they've learned in code.org to what they're doing with the robots. Now, guided practice is that next step. This is where you're going to start incorporating student volunteers in that activity. Basically, in our Blockly app, we now have sequenced preset programs in the app that walks through each of those coding concepts. And within the lesson, it tells you which preset program to open up and walk through with your students and help them basically manipulate that app and really expose that coding concept. And last but not least, we have that independent practice section where we tell you to push those students to add more to the preset program. The reason why we start with that is I believe one of the scariest things in the world is a blank page. And that preset program basically helps kids start with something and manipulate before they tackle the challenge cards where they have to start from scratch. This is also a point where you can also fold in those Blockly puzzles that we love dearly that are in the app as well. Last but not least, I want to mention that with these lessons, if you go to that main page at the very bottom with resources, you can click on a PDF and it actually shows that alignment with CSTA and ISTE. And at the end of every single lesson online, we have CSTA, ISTE, NGSS, and Common Core standards listed on the bottom of every single lesson. And for all you Texans out there, we've got TEKS alignment on the way, all right? Hopefully by the end of this month. Jenny's like, yippee! Now I'm noticing a lot of questions about the subscription. Now what the subscription is tied to is actually our Code to Learn lesson library, which is the other half of our curriculum page. And these Code to Learn lessons are actually project-based, cross-curricular lessons that we recommend your students do after they've gone through those 6 coding lessons. Because here, instead of learning to code, they're coding to learn. They're basically coding to learn about ELA concepts, math concepts, science concepts, and social studies concepts as well. Now, your subscription that came with the curriculum guide, that helps you unlock those premium lessons because these lessons are multi-day project-based lessons. We put a lot of heart and a lot of labor into building these lessons. So we thought, you know what, this is premium stuff. It's just for our subscribers. Here's some more information about it. Now, I'm curious because our Code to Learn library has been out there for a while, and this is breaking news. We are about to start launching 5 new lessons every month for the next 6 months, so keep your eye out for that. But for any of those who have anybody used our Code to Learn library before? Have you tried any of our lessons? And if you have or have not, what would you want to see in the Code to Learn library? Remember, these are project-based, cross-curricular lessons using Dash and Dot. Oh, Dance the Loop-de-Loop, I love that lesson. Has anyone done the lumber line? URL for Code to Learn. Brian, do you mind providing that link there, or June?
Yep, I'll copy and paste it in.
Denise, are you removing the free access we have? You mean there are some lessons that are free in our Code to Learn lesson library? Yes. We'll always have a couple free lessons there for you guys to try, and every single one of those lessons you can preview as well. So you can get a sense of all those lessons before you decide to subscribe. Yeah, so if you haven't tried them, yeah, June says all the lessons that have been, so we have a submit a lesson section, and all the lessons that were submitted by teachers for free are available for free in our library. The only ones that are premium are the ones that we've developed in-house with teachers. So we actually will pay teachers to write these lessons for us, and then we go through a whole editing process. We create the art assets and publish it professionally on our page as well. And yes, the subscription does include this. So basically, if you have access to the premium last year, to continue having access to that, you would need to renew your subscription. It lasts for 1 whole year though. So I'm gonna continue, guys. I know time's a ticking. Before I go, I definitely recommend you guys checking out some of these lessons. The ones I would really recommend, $60 a year, Denise. The ones I would really recommend are Dash's Basketball Challenge, which is a challenge that we were featuring at our conference booths. That one's a free lesson for you to try out. A couple other ones are the number line ones are great, where you actually create a number line with Dash, and Dash has to move along that number line. So it's a great math concept one. Dance the Loop-de-Loop is great, and there's also one where you're actually creating a timeline, a historical timeline with Dash as well. Now, I wanted to walk you through an example of how you would progress through all of these components, because I know I just went through a lot of components, right? So this is the whole idea of acquiring, practicing, and then applying is what I want to demonstrate here. You can acquire your coding concepts with your students with a couple sessions with code.org. We love code.org. You know, you shouldn't give it up. You should definitely do some sessions with code.org. And after that, what you should do next is use those Learn to Code lessons, right? Like we said, we have those unplugged lessons, and those unplugged lessons feature Dash and Dot so they can get acquainted with, how is this robot going to actually work with the coding concepts? And from there, you can also introduce challenge cards so they can practice those coding concepts. And remember those the solution guide in our curriculum guide, you can use that content to help them have even more in-depth practice. And also in that solution guide, the apply, remember we have those cross-curricular connections, that's gonna help them apply those coding concepts to cross-curricular concepts to Code to Learn. And last but not least, we talk about that Code to Learn lesson library. So after they've completed those 6 lessons, then port them over to project-based learning, then allow them to apply what they've learned with coding to something exciting where they're gonna build something on their own. Now, I'm going to stop here because that was a very long introduction. Any questions, I just want to remind you guys, please put them in Q&A, the Q&A section, and I'll definitely start addressing them. But I wanted to give you guys, I'm going to pause for another 10 seconds to allow you guys to add some more questions to Q&A. All right. Going to continue, guys. A little bit left. The last thing I want to do is walk you guys through an example. Like I said, I showed you that whole progression, but I wanted to walk you through a very specific set of challenge cards. All right, you guys ready? All right, so this example, this is one of my favorites. It's level E, and it talks about functions. And the theme with this set of cards is that Dash is a puppy, and you, the user, are its owner or trainer. All right. So the first thing you're going to do with this theme is, like I said, you can access our coding lesson online. That's connected to the set of challenge cards, right? And here it's going to actually tell you which challenge cards you need for this lesson. And within here, we have a Blockly preset program that showcases how functions are used in Blockly. In this one, you use actually dot to do different functions as well. And then what happens is they go through the cards, and these cards progress in difficulty while still keeping that theme. So in the beginning, the dog trainer teaches the dog one trick, right? How to spin. In the second card, you have to teach the dog 2 tricks. And last but not least, now you have to run your Dash the Puppy through an obstacle course. I just took my dog to agility training. I know how hard it is. So, you know, that final card is actually really fun. They actually build their own obstacle course. Last but not least, as they're doing those challenge cards, like I said, they're going to use those planning worksheets to plan out that obstacle course. Like I said, they're going to check off their cards as they complete them on the checklist. And at the end, they're going to reflect on their work. And then you're going to be able to evaluate that work once they're done. And then once they completed those challenge cards, they've completed those lessons, those challenge cards, you can explore having those cross-curricular connections as well, right? So for example, in this one, for that final card, as Dash was moving through that obstacle course, have the students add up the total number of centimeters that Dash traveled while they were navigating that obstacle course, right? And in the ELA, have them write a story, okay? Talk about the advantages. Oh, this one actually, yes. This one, you actually have to guide one of your other students through an obstacle course, okay, and describe it by writing a paragraph. So as you can see, that's ELA, the sort of instructional writing as well. And from there, then you can go to our Code to Learn lesson library. Right here, there's a lesson called Geometry with Dash, where actually, remember how they're doing the obstacle courses by going through squares and circles? In Geometry with Dash, they're going to use functions to develop shapes, right? They're going to actually program Dash to do different shapes, and then you can call that function and create a square or a circle. And last but not least, as many of you guys know, we have our annual robotics competition open for registration right now, and that is a great cross-curricular extension as well. This year's theme is actually space themed. It's actually tied to the solar eclipse that many of you guys got really excited about. So it's definitely worth checking out the robotics competition. That's a great additional extension that kids can do after they've gone through those coding challenges. Now, I noticed you guys asked for lots of links. June's been doing great offering these links. I just wanted to walk you through more, okay? So these are the additional resources, but before I do that, I wanted to ask you guys, what other resources have you used in working with our robots? Because I know there's a lot out there, so I'd love to hear. Kristen, how can we use your, so definitely, Kristen, if you go to our website, you can find the robotics competition. Once you set up a team, you get all those resources that walk you through how to implement those competition challenges in your classroom. And next week, I believe Derry Stevens, who's running that robotics competition, will also be hosting a webinar. Brian, if you could provide that link, that would be great. So if you need any more guidance there, you have lots of resources on our website. All right, well, if you guys have any other questions, once again, please put them in Q&A. So I'm going to walk you through Pinterest. Yes, we know Pinterest is very popular. Now, maybe I should start from there. We do have a lot of social network going on here. We have our Twitter account, our Facebook account, and our Instagram account, which I have listed on the bottom. And Derry Stevens, like I mentioned, who's running the robotics competition, is always pushing content there. Okay, definitely go there, and she's going to post information about, for example, this webinar. We share fun articles, we share links, we share videos. It's a great place to just get more ideas. Now, the other resources that I've talked about a little before is our blog, right? blog.makewonder.com is a great place where you can basically check out these articles that we've been writing. Teachers write articles for us too. We also have industry professionals talking about the benefits of robotics and coding as well. Like I said, a couple to look out for is that design thinking curriculum that I told you guys about. Someone said they wanted to print out. I have a whole blog article about the design thinking process and how we use it to design our curriculum. And there's one just specifically about carts and storage for our robots. So definitely check that website out for more articles. The other place you can check it out is at education.makewonder.com. We have a whole professional development section. There we have some getting started videos about unboxing Dash, setting it up, and walking you through all those different apps. And at the bottom, you can actually also sign up for an in-person workshop. We partnered with Eduscape to basically have that in-person experience as well. And last but not least, that robotics competition that I've mentioned, we have a whole other section on our education website where you can get more information and figure out how you can sign up for that as well. So that's about it. Questions and suggestions. Oh, yes. Before I go to Q&A panel, I wanted to address this one. This is a really great question from Stephanie W. from Connecticut. How do we reset challenges and things students have already completed? You have multiple classes coming in on the same day and want to reset things for them. What is the best way to do it? Well, surprise, surprise, we at Wonder Workshop worked really hard to launch this reset capability right before ISTE this year. So if you go to Blockly and you go to the puzzles, at the very top, next to the word puzzles, you see a little icon. If you press on that, you actually get to reset the puzzles. Now you no longer have to delete that app or do anything else. You just press that button and you're resetting for the students once again. Now for Wonder, this has already existed for a while, but I wanted to walk you guys through this again. In the Wonder app, Kristen's like, yeah, I agree. I was also really happy when we implemented that. And Wonder, there's a secret mode that you can access by holding down on Eli's head, then tapping free play, then Inventions Log, then free play again, and you're opened up to this menu. And one of those menu items is to reset that app or to unlock some of the features, just in case the kids haven't completed all the puzzles yet. So before I go into sneak peek mode, I think I'll try to do Q&A for a couple minutes, June, and then we'll do sneak peek. Sound good? All right, let's look at Q&A. If I can, you know what? I'm going to have to escape out of here. Give me 1 second. Q&A, let's go. I'm a teacher in special ed. Do you have any ideas or suggestions as to how I might modify the curriculum for nonverbal autistic students? We rely heavily on picture-based instruction. That's a really great question, Jennifer. We've been getting a lot of feedback from special ed teachers, and actually I, in college, volunteered with a program that worked with kids with disabilities. And we've actually shown that a lot of autistic kids love using our robots. Now, one thing I would recommend, a great activity, is talking about emotion with our robots and having them act out that expression by recording their voice with the robots and playing it back. It's also a great way to practice dialogue as well. And with this picture-based instruction, Blockly, the walkthroughs all have little illustrations, so go through those Blockly puzzles for sure. And last but not least, try those unplugged lessons that we have online. Those are all visual-based as well. How many dash and dots do you, so I answered that live. Guys, this is my first time doing Q&A, so done, okay. How many dash or dots do you recommend for a class of 20? My general rule of thumb is 1 robot for every 2 to 3 students, okay? 2 to 3 students. So here for 20, you're looking at about 10 robots. You can get away with a little less, but 10 would be the most ideal number. Do the ABCD levels? Yes, they do. So our coding levels align to Code.org's course levels. So every one of our coding levels addresses similar coding concepts to the course levels in Code.org. Laura also asked that question. Cool. Barbara, here we go. This summer, PDF was sent out to preview. It looked like wonderful. Okay, so the PDF we had was for testing window. We were testing out our cards and we were getting feedback. So once we got that feedback and we printed the cards, we no longer needed that feedback, so we closed that PDF. So I'm sorry about that. I wanted to thank you for anyone here who provided that feedback. Everyone got a free box of cards for giving that feedback as well. But now, you know, you can go to our store and buy a box of cards, $39.99. We will be we'll have another feedback window for new content, and we'll be announcing that later on next year. Will this program work on a laptop if tablets are not available? Currently, they don't work on a laptop right now, but you know, we'll keep you updated if we develop that. The curriculum guide currently cannot be purchased separately. Correct, June?
Yes, but you can email if you want to. So we will be putting it on our website soon to be purchased separately. For now, though, you can email teachers@makewonder.com to purchase it.
Yep. I don't know if you could hear, but yes, if you email us, we can offer that as an option. It's currently not available at our stores. Chromebook compatibility, I know that's been a big question, you guys. We are working hard on that. We can't promise a date, but let's just say it's one of our priorities, our main priority for next year. So if you are coming to one of the conferences, please stop by our booth because we'll have some demos for you guys to try out for that. Can the curriculum, like, okay, we did that one. Do you suggest starting with A 1.1 even with older students if dot and dash are new to us? I actually do. If you have older students, they're going to zip through coding levels A, B, C, but it's a great way for them to get acclimated to the app and also to our robots. How to distribute challenge cards. So what I recommend, and that's why all of our learning bundles have one box of cards for every dash. Really, for every robot that you have, you should probably have a box of cards. Now, I know sometimes funding is not great. So when I talked about differentiated groups, it's another way you can do it. So you can stretch that box of cards. So you basically group kids by different coding levels, and then you pass them out different card sets that they can walk through. Now, once they complete it, if another group needs it, they can go and talk to that other group, right? So that way you can share one resource easily. Okay, a few more. Does it take much storage to store all these challenges? Actually, when you buy the challenge card box, we put a lot of time into designing that box so it becomes your storage solution. There's tabs inside so you can easily sort and put those cards back. So I really recommend just keeping that box, and that can help you sort and store your challenges. It's not a very big box at all either. Will I be at MassQ this year? I will let Brian answer that. Is the curriculum guide additional or does it come with the cards? If you buy the Learn to Code curriculum pack, it will come with the cards. So the Learn to Code curriculum pack comes with the cards, the guide, and also that subscription to the Code to Learn lesson library. Okay. All right. I know we have a lot more questions here. I'm going to answer by text later on. I believe I can do that, right, Brian? If Brian's here.
That's correct. Yep.
Okay, so I'm going to answer later on. I want to make sure we get to this because you guys, for coming to our webinar, get this awesome sneak peek to
And
a
Charlotte,
new...
I can jump in here and answer some by text as well.
Okay, thank you, Brian. Okay, so you guys get a brand new sneak peek at a new accessory we're building for Dash and Q. Now, this is a sketch kit. And it's a pen tool for your robot. Now, I know a lot of you guys have already built pen tools with your students, and this is gonna make it a lot easier for your kids to jump to that drawing activity. Now, with this sketch kit, as you see, you have a pen holder and a set of pens. Now, these are erasable pens, and we're gonna have a whiteboard map, basically, that goes with this sketch kit, so that the robot can draw on the whiteboard mat, you can erase it, and then use it all over again. Here are a couple other shots of the sketch kit, and I'm gonna let June ask some questions. June, you had some questions for them?
Yeah. So in general, we were just wondering if you have feedback on. So we think that the sketch kit is going to be great for math integration. Drawing polygons, circles, ellipses, also graphing something on a coordinate grid.
There's art is great too, geometry, ways to draw characters, and also storytelling as well.
Yeah, and we were wondering if you had any feedback, questions, concerns, whether it's like, great, this looks great, or if you could write in the comments any first impressions or things that you think we should think about when releasing these. They will come with some challenge cards, and so we will put those in the box.
Yes,
like Charlotte is showing, of some easy things for the kids to start drawing and some more complex things.
Yeah. And we're getting questions about whether the pens are refillable. We'll be having replacement packs, and June and I are working hard to make sure that those refillables are price savvy. Like they'll be affordable.
Affordable and easy to get, like through Amazon, Prime, things like that.
And definitely it does go along with code.org. We know there's that sketch activity. The kids love it. We're planning to have a pen up and pen down function within Blockly at the very least, so that kids can experience that pen up, pen down with the robot as well. In Canada, well, we're hoping so. Yes, see this in math. And if you guys have any activities that you might want to do with the sketch kit, this is also a great opportunity to give us feedback about that. That way, as we're designing the curriculum, we can start incorporating those ideas as well.
Yes, and I'm seeing some questions about adapting to other markers. We are going to release an adapter for the skinny like skinny Crayola markers and skinny Expo markers. So there's like the fat one, which is too fat for the for the robot, because we also have it in the center of rotation, so you can draw accurate shapes. And let's see, the pen comes off and on easily. Yep, and it works with both the Old Dash and Q. Cool. And yeah, so we are planning to launch this in the spring. And so yeah, we're excited to.
Yeah, keep your eye out there.
Keep your eye out. And if you guys are interested in piloting it, we will get some early units this fall. And so after the webinar, we'll send out an email with kind of like a survey of what you think, and also if you're interested in piloting it, and we will send one out to you for free.
Woohoo! We already have some volunteers
for some feedback.
Yeah.
Yep.
Yeah, it's just like the challenge cards, guys. When we had that window for feedback, we definitely we value your input, and we know how you guys know what best to do with these pens. Teachers in training. Oh, yes, the professional development. Like I said, we were partnered with Eduscape, so you can sign up for workshops on our website as well, and we are working to develop and expand our professional develop as well. Brian, how are we on time? Like, I can answer a couple more questions.
So we're actually going to wrap up. I'm going to stop the recording, but any questions that you want to continue to answer, you can continue to do so. In the Q&A panel, I've gone through and I've answered a ton of them. So if you check the answered section, I answered them via text. So you can find your answers through there. But at this point, I'm going to stop the webinar recording. So I want to thank everyone for attending. As a reminder, everything is going to be, everything has been recorded, so you can go back and watch this at any time, and we'll be sending you an email within the next day or two once everything's done compiling with the link to be able to do that, so you can share that with your fellow teachers. And then if there's anything else that you need, you can always reach out to us at teachers@makewonder.com, or you can get a hold of Charlotte, June, myself, anyone on the education team through that email. So be sure to say hi to us at any conferences. We love hearing from all of you as educators, and we love seeing you out and about, so be sure to say hi. I want to thank Charlotte and June for jumping on as well. Charlotte, this was an incredible webinar, so thank you for answering so many questions that people have had about the curriculum and how they can get started using our robots in their classroom. So at this point, I'm going to bid everyone a farewell, and we can stay on and hang out here and answer questions for the next 10 or so minutes. Thanks, guys.
Yep.